Earth is a unique planet in our solar system. It is made up of different layers, each with its own properties. These layers include the crust, the mantle, and the core. The deeper we go, the hotter and denser it becomes. Understanding Earth's structure helps us learn about natural events like earthquakes and volcanoes. It also helps scientists study the planet's history and predict future changes. In this article, we will explore Earth's layers, focusing on its mysterious inner core. Earth is like a giant ball with multiple layers, similar to an onion. Each layer has different materials, temperatures, and characteristics. Scientists divide Earth into three main layers: the crust, the mantle, and the core. Crust. The crust is the outermost layer of the Earth. It is the part we live on, covering the entire planet like a thin shell. Compared to the other layers, the crust is very thin, only about 5 to 70 kilometers thick. It is made up of solid rocks, minerals, and soil. Earth's crust has two types: oceanic crust and continental crust. Oceanic crust is found under the oceans. It is thinner, about 5 to 10 kilometers thick, but denser because it is made mostly of basalt, a dark volcanic rock. Continental crust forms the land masses. It is thicker, about 30 to 70 kilometers thick, and made of lighter rocks, like granite. This is why continents float higher on the mantle compared to the ocean floor. Even though the crust is solid, it is not a single unbroken piece. It is divided into large sections called tectonic plates, which float on the mantle and slowly move over time. Mantle. The mantle is the middle layer of the Earth. It extends from the bottom of the crust to a depth of about 2,900 kilometers. It is much thicker than the crust and makes up about 84% of Earth's total volume. The mantle lies just beneath the crust and is mainly composed of hot semi-solid rock called silicate minerals. Due to the high pressure and temperature, the rocks here can slowly flow, like thick syrup. The upper part of the mantle, combined with the crust, forms the lithosphere. Beneath it is a softer layer, called the asthenosphere, where rocks move slowly in a process called convection currents. These movements push and pull the tectonic plates, causing earthquakes, volcanic eruptions, and the formation of mountains. Core. At the center of the Earth is the core, the hottest and densest layer. Scientists divide it into two parts: outer core and inner core. The outer core is a liquid layer made mostly of iron and nickel. It is about 2,300 kilometers thick and surrounds the inner core. The movement of the liquid metal here creates Earth's magnetic field, which protects us from harmful solar radiation. The inner core is a solid sphere made mostly of iron and some nickel. It has a radius of about 1,220 kilometers. Even though it is extremely hot, about 5,000 to 6,000 degrees Celsius, it remains solid due to the immense pressure from the layers above. The core is essential to Earth's structure and function. It influences the planet's magnetic field, climate, and even the movement of tectonic plates. Next, we will explore the mysteries of the inner core, including recent discoveries about its changing shape. The inner core is one of the most mysterious parts of our planet. Even though humans have never traveled deep enough to see it, scientists have learned a lot about it through indirect methods, such as studying seismic waves from earthquakes. The inner core plays a key role in Earth's structure, influencing the planet's magnetic field and stability. For many years, scientists believed that Earth's core was completely liquid. However, in 1936, Danish seismologist Inger Lehmann made a groundbreaking discovery. While studying earthquake waves, she noticed that some waves behaved as if they were bouncing off a solid object deep inside the Earth. From this evidence, she proposed that Earth's core has two parts: a liquid outer core and a solid inner core. This discovery changed our understanding of the planet's structure. Over the years, scientists have continued to study the inner core. They have found that it is not only solid, but also grows very slowly. Every year, a thin layer of solid iron forms on the inner core as the outer core cools. This slow growth has been happening for over 1 billion years. The inner core is mainly made of iron, AFE, and nickel, Ni, with small amounts of other elements like oxygen, sulfur, and silicon. It is about 1,220 kilometers, 760 miles in radius, which is slightly smaller than the Moon. Despite its small size compared to the rest of the Earth, the inner core is extremely dense and heavy. Scientists have also discovered that the inner core is not perfectly uniform. Some studies suggest that different parts of it may be made of slightly different materials or have varying levels of hardness. In recent years, researchers have even found evidence that the inner core's shape might be changing, though this is still being studied. The inner core is the hottest part of the Earth. Its temperature is estimated to be 5,000 to 6,000 degrees Celsius, 9,000 to 10,800 degrees Fahrenheit, similar to the surface of the Sun. However, despite this extreme heat, the inner core remains solid because of the immense pressure from the layers above it. The weight of the Earth's crust, mantle, and outer core compresses the inner core so much that the iron cannot melt, even at such high temperatures. To understand this pressure, imagine holding a small object in your hand. Now, picture the weight of the entire planet pushing down on that object. This is what happens to the inner core. The pressure is about 3.6 million times greater than the air pressure at sea level. Scientists believe that the inner core may not be completely motionless. Some studies suggest that it rotates at a slightly different speed than the rest of the Earth. This movement, along with the liquid outer core's flow, helps create Earth's magnetic field, which protects us from harmful solar radiation. In the next section, we will explore recent discoveries about changes in the inner core, including how its shape might be shifting over time. In recent years, scientists have made intriguing discoveries about Earth's inner core, revealing that it is not as static as once thought. These findings suggest that the inner core's shape and rotation are changing over time. Traditionally, the inner core was believed to be a solid, unchanging sphere, composed mainly of iron and nickel. However, recent studies analyzing seismic waves from earthquakes have provided new insights. Researchers have observed that the inner core may undergo viscous deformation, meaning its shape can change slowly over time. This deformation is thought to occur near the inner core's surface, and is likely caused by interactions between the inner and outer core. Additionally, analyses of earthquake waves have suggested that around 15 years ago, the inner core's rotation may have slowed significantly, to the point where it appeared to pause or even reverse direction relative to Earth's surface. This observation indicates that the inner core's dynamics are more complex than previously understood. The discovery that Earth's inner core is changing shape and rotation has several important implications. Earth's magnetic field. The movement of the liquid outer core generates Earth's magnetic field. Changes in the inner core's rotation and shape could influence the dynamics of the outer core, potentially affecting the strength and structure of the magnetic field. A weakening or alteration of this field could have implications for navigation, satellite communication, and protection from harmful solar radiation. Geological activity, the interactions between the inner and outer core, may also impact mantle convection currents, which drive plate tectonics. Understanding these changes could provide insights into the processes that lead to earthquakes and volcanic activity. Planetary evolution. Studying the inner core's dynamics helps scientists learn more about Earth's formation and evolution. It offers clues about the thermal and compositional history of our planet, shedding light on how Earth's internal processes have changed over time. These findings underscore the importance of continued research into Earth's inner core. By improving our understanding of its behavior, scientists can gain deeper insights into the complex systems that govern our planet. In the next section, we will explore the significance of the inner core in generating Earth's magnetic field and its impact on life. The inner core is more than just a dense, hot ball of metal at the center of the Earth. It plays a crucial role in maintaining life on our planet. One of its most important functions is generating Earth's magnetic field, which protects us from harmful space radiation. Without the inner core, Earth would be a very different and much less hospitable place. The Earth's magnetic field is like an invisible shield that surrounds the planet. It protects us from solar wind, a stream of charged particles constantly released by the sun. If these particles were not deflected by the magnetic field, they could strip away Earth's atmosphere and damage life. But how is this magnetic field created? The key lies in the interaction between the inner core and the outer core. The outer core is made of liquid iron and nickel, which move due to Earth's rotation and heat from the inner core. As the hot metal moves in swirling currents, it generates electric currents. These electric currents create a magnetic field through a process called the geodynamo effect. The inner core plays a vital role in this process because it helps control the flow of the liquid outer core. Without the solid inner core, the motion of the outer core might not be stable enough to generate a strong and lasting magnetic field. The magnetic field generated by Earth's core has a direct impact on all life on the planet. Protection from solar radiation. The magnetic field acts like a protective bubble around Earth. Without it, harmful solar radiation would reach the surface, damaging DNA and increasing the risk of cancer in humans and animals. The field also prevents the atmosphere from being stripped away, as happened on Mars, which lost most of its magnetic field billions of years ago. Navigation for animals and humans. Many animals, such as birds, sea turtles, and bees, use the Earth's magnetic field for navigation. Scientists believe that tiny magnetic particles in their bodies help them sense the direction of the field, allowing them to migrate long distances. Humans have also relied on the magnetic field for centuries. Compasses work because of it. Technology and satellites. The magnetic field protects modern technology, including satellites and power grids, from solar storms. If the field were to weaken or disappear, strong solar storms could damage electrical systems and cause global communication failures. The inner core's role in creating Earth's magnetic field is essential for maintaining a stable environment where life can thrive. If the inner core were to stop functioning, the consequences could be severe, leading to increased radiation, disrupted ecosystems, and damaged infrastructure. The inner core may be hidden deep beneath our feet, but its impact reaches far beyond the center of the Earth. It helps generate our magnetic field, protects life from dangerous space radiation, and even supports modern technology. Recent discoveries about changes in the inner core remind us that Earth is constantly evolving. Scientists continue to study this mysterious part of our planet, uncovering new secrets that help us understand Earth's past, present, and future.